In fluid mechanics, the term static pressure has several uses. In the design and operation of aircraft, static pressure is the air pressure in the aircraft's static pressure system. In fluid dynamics, many authors use the term static pressure in preference to just pressure to avoid ambiguity. Often, however, the word static may be dropped, and in that usage, pressure is the same as static pressure at a nominated point in a fluid. The term static pressure is also used by some authors in fluid statics. Static pressure in design and operation of aircraft. An aircraft's altimeter is operated by the static pressure system. An aircraft's airspeed indicator is operated by the static pressure system and the pitot pressure system. The static pressure system is open to the exterior of the aircraft to sense the pressure of the atmosphere at the altitude at which the aircraft is flying. This small opening is called the static port. In flight, the air pressure is slightly different at different positions around the exterior of the aircraft. The aircraft designer must select the position of the static port carefully. There is no position on the exterior of an aircraft at which the air pressure, for all angles of attack, is identical to the atmospheric pressure at the altitude at which the aircraft is flying. The difference in pressure causes a small error in the altitude indicated on the altimeter, and the airspeed indicated on the airspeed indicator. This error in indicated altitude and airspeed is called position error. When selecting the position for the static port, the aircraft designer's objective is to ensure the pressure in the aircraft's static pressure system is as close as possible to the atmospheric pressure at the altitude at which the aircraft is flying, across the operating range of weight and airspeed. Many authors describe the atmospheric pressure at the altitude at which the aircraft is flying as the free-stream static pressure. At least one author takes a different approach in order to avoid a need for the expression free-stream static pressure. Gracie has written, "The static pressure is the atmospheric pressure at the flight level of the aircraft." Gracie then refers to the air pressure at any point close to the aircraft as the local static pressure. Static pressure in fluid dynamics. The concept of pressure is central to the study of fluids. A pressure can be identified for every point in a body of fluid, regardless of whether the fluid is in motion or not. Pressure can be measured using an aneroid, Borden tube, mercury column, or various other methods. The concepts of total pressure and dynamic pressure arise from Bernoulli's equation and are significant in the study of all fluid flows. To avoid potential ambiguity when referring to pressure in fluid dynamics, many authors use the term static pressure to distinguish it from total pressure and dynamic pressure. Static pressure is identical to pressure and can be identified for every point in a fluid flow field. In aerodynamics, L.J. Clancy writes, to distinguish it from the total and dynamic pressures, the actual pressure of the fluid, which is associated not with its motion but with its state, is often referred to as the static pressure. But where the term pressure alone is used, it refers to this static pressure. Bernoulli's equation is fundamental to the dynamics of incompressible fluids. In many fluid flow situations of interest, changes in elevation are insignificant and can be ignored. With this simplification, Bernoulli's equation for incompressible flows can be expressed as where is static pressure, is dynamic pressure, usually denoted by is the density of the fluid, is the flow velocity, and is total pressure, which is constant along any streamline. It is also known as the stagnation pressure. Every point in a steadily flowing fluid, regardless of the fluid speed at that point, has its own static pressure, dynamic pressure, and total pressure. Static pressure and dynamic pressure are likely to vary significantly throughout the fluid, but total pressure is constant along each streamline. In a rotational flow, total pressure is the same on all streamlines and is therefore constant throughout the flow. The simplified form of Bernoulli's equation can be summarized in the following memorable word equation. Static pressure plus dynamic pressure equals total pressure. This simplified form of Bernoulli's equation is fundamental to an understanding of the design and operation of ships, low-speed aircraft, and airspeed indicators for low-speed aircraft, that is, aircraft whose maximum speed will be less than about 30% of the speed of sound. As a consequence of the widespread understanding of the term static pressure in relation to Bernoulli's equation, many authors in the field of fluid dynamics also use static pressure rather than pressure in applications not directly related to Bernoulli's equation. The British Standards Institution, in its Standard Glossary of Aeronautical Terms, gives the following definition. 4412 Static pressure, the pressure at a point on a body moving with the fluid. Static pressure in fluid statics. The term static pressure is sometimes used in fluid statics to refer to the pressure of a fluid at a nominated depth in the fluid. In fluid statics, the fluid is stationary everywhere and the concepts of dynamic pressure and total pressure are not applicable. Consequently, there is little risk of ambiguity in using the term pressure, but some authors choose to use static pressure in some situations.